Hello, this is part D of the Chapter 5 lesson. In this part we're going to talk about the continuous probability model that we call the normal distribution. And so to illustrate this, suppose that men age 60 have a body mass index with a mean of mu equal 29 and a standard deviation of sigma equals 6. So let's stop right there and talk about what this means. So this means that if we were to go out and collect the body mass index of all men age 60, add them up, and divide by the total number of men age 60, we would get a mean of 29. And then if we calculated the standard deviation of all of those BMIs using the formulas from the last chapter, we would get a standard deviation of 6. So these numbers here, mu and sigma, are population parameters. This describes the mean of the population and the standard deviation of the population. Now, a question that we might ask is, suppose we randomly select a 60-year-old man. What's the probability that his body mass index is less than 30? It sounds like a reasonable question we might ask. Well, this sounds like somewhat similar to a question that we saw in part C of this lesson, where we used the binomial distribution. But let's make an observation here. Note that the BMI is a continuous variable. It does not have to be a whole number. It can take on any value between 0 and some theoretical maximum, so it's continuous. So that means that the binomial distribution is not appropriate. Remember, the binomial distribution dealt with only discrete variables. So we need a different type of probability model. And that probability model that we're going to use here is called the normal distribution. And here's a formula for our normal distribution. Now don't let this scare you. We're not actually going to use this. What this formula is an equation that describes this so-called bell curve that we saw earlier in the semester when we talked about the normal distribution. If we were to graph this like we did in high school algebra, we'd get a bell curve that looks something like this. Some significant aspects of this curve is that our mean mu is right in the middle. The curve is bell-shaped and it's symmetric. Now, we're going to use this formula in a little bit different way than what we did with the binomial distribution. This formula in and of itself doesn't give us probabilities. What we do, how to get probabilities, is we use areas underneath this curve to give probabilities. Okay? So what do I mean by that? So let's go back to our example of what's the probability that a male has a body mass index less than 130. So let's let the variable x represent the BMI of a single male. Now this variable x is what's called a random variable. This idea of a random variable forms the theoretical foundation for everything that's done in probability and statistics. So in terms of this variable, in mathematical notation, we want to know the probability that x is less than 30. That's always the first step in a problem like this, is to write what it is we want to know in mathematical notation. Now, how we're going to get this probability from this bell curve is illustrated here in this picture. So here we have our bell curve. Our mean of 29 is right in the middle. Remember, the population mean of 29 was given back on the first slide. And we want to know the probability that x is less than 30. So if we go over to 30, draw a vertical line, the area underneath the bell curve to the left of 30 is our probability. So this area equals the probability that we want to know. Now, calculating this area is not a trivial matter, and we're not going to talk about the mathematical details behind how this is done. Instead, we're going to use these built-in formulas from this workbook chapter 5, which we used in part C of this lesson. If you go to the worksheet normal, you'll see some cells that look like this. And again, yellow things are things that we can change, green are what's automatically calculated. And so this asks for four numbers: mu, sigma, A, and B. Mu is our population mean, which is 29 in this case. Sigma is our population standard deviation, which is 6. A and B are the numbers that we see inside the parentheses. And so we're going to be able to use this to calculate probabilities of three different types. One type is where x is between two numbers. A is the smaller number, B is the larger number. We can calculate the probability that x is greater than some number. We can calculate the probability that x is less than some number. In this case, we want to know the probability that x is less than 30. And so we want to calculate a probability of this type. So what we're going to do is enter that number 30 here into both of these cells for A and B. And the number that's given right here is our probability. So the probability that x is less than 30 is 0.5662. Now, the book talks about other ways of calculating this by calculating z-scores and using tables, and we won't get into all those details here. We'll just focus on understanding how to use the workbook to calculate these probabilities. Okay. Now, here's a different question. We might ask, what's the probability that a male has a BMI that's greater than 27? Now, in terms of our bell curve, this is the area underneath the bell curve to the right of 27. But we want, again, we let the random variable x represent the BMI of a male. We want to know the probability that x is greater than 27. And so to calculate this, we'll again use this workbook, chapter 5. We've got the same value of mu and sigma, but now we've got this number 27 inside the parentheses, so we'll enter that for A and B. In this case, we want to know a probability of this form right here, and so here's our answer, 0.6306. So 0.6306. Now, what does that mean in a practical sense? Well, that means that about 63% of all males in this population have a body mass index of greater than 27. Let's do another example. What's the probability that the male has the BMI between 28 and 32? So, same random variable. In this case, we want to know the probability that x is between 28 and 32. And so now we have two numbers in our parentheses. In our workbook, we're going to enter same value of mu and sigma. Here's the value of A, the smaller number, the value of B, the larger number. We want to know probability of this form, and so there's our answer, 0.2576. What does that mean in a practical sense? Well, that means that about 25% of all males in this population have a BMI between 28 and 32. Now, next we're going to talk about something called percentiles, which are kind of generalizations of the idea of quartiles that we saw back in chapter 4. A number p is called the 90th percentile of a random variable x if the probability that x is less than p is equal to 0.9. Now, there's nothing special about the number 90. That number could be changed to any number between 0 and 100. So a percentile is a number, and it's a number for which the probability that x is less than that number equals the percentile, the 90th in this case. So as an example, let's find the 90th percentile of the BMI for men. So to illustrate what we mean by that, or better define what it is we mean, let's let our random variable x again denote the BMI of a single man. And so we want to find a body mass index, call that number p, such that probability that x is less than p is equal to 0.9. And the book talks about the details for how to calculate this, but if we go back to that workbook chapter 5 and go to the worksheet called percentiles, this will automatically calculate percentiles for us. All we need to do is enter mu, p or sigma, and then the probability. So that's this right hand side, 0.9. And so then it automatically calculates the percentile over here of 36.69. And so our solution to this problem would be to say that the 90th percentile is the number 36.69. Okay. Now, what does that mean, that the 90th percentile is 36.69? That means that the probability that x is less than 36.69 equals 0.9. Or stated another way, about 90% of men have a BMI less than 36.69. Now, to verify that this probability really is true, if we go back to that worksheet normal, let's calculate this probability here and just verify that it does equal 0.9. So here's our mean, our standard deviation. We have only one number inside the parentheses, so we enter that number here for A and B. And we want to know a probability of this form right here, that x is, no, excuse me, we want to know a probability of this form, that x is less than some number. And so here's that probability, 0.9, and that's exactly as we claimed it to be. So that's how we calculate percentiles, and this is what the 90th percentile means. Yeah, so again, to illustrate, what does this mean, that the 90th percentile is 36.69? This means that about 90% of men have a BMI less than 36.69. Now let's do another example of calculating percentiles. Let's find the 30th percentile. And so to find the 30th percentile with our workbook, our worksheet percentile, we'll enter our mean, our standard deviation, and our probability. In this case, we're dealing with the 30th percentile, so our probability is 0.3. And so here's our percentile, 25.85. So that means our 30th percentile is 25.85, which means that about 30% of men have a BMI that's less than 25.85.